Hello. Hey everyone. So I'm Rahul Saxena and I work for a blockchain company called zkSync. And zkSync is what makes blockchains faster. So when you try to do that, you have to mess a little bit with the cryptography. Cryptography is maths, maths is hard, so you make mistakes, and I tend to stop people from making mistakes. That's why I work for the zk security. So, just to get a room check, how many of you have heard of blockchain but never really delved into it, not really understood what it is? That's good. That's good. Okay. So this front row is okay. Anyway, uh, just to get a little bit more context, if I say layer two, what does that mean to you? Like, does that mean anything at all? Layer 2 solution, does that mean anything? Apart from the first row, don't answer, yeah.
So we club the transactions and then write it on the chain.
It what?
Basically, we club the transactions together
Uh-huh.
and it provides solutions for that instead of like it reduces the gas fees.
Okay. Uh, it's fine, it's not wrong. Are several nuances to it, but okay. I get the feel for the room. And instead of jumping right into what ZK is, what zero knowledge is, let's start from the very basics of what blockchain is, okay? And even before that, let's start with why do we even need blockchains? Is that all cool with you guys, or do you think that would be boring? All cool? Sure. So, okay, there, whatever. Does this work? No? Okay, so the agenda for today's talk would be introduction, what is, doesn't matter, let's pretend that. So, an introduction of what actually? An introduction of anything blockchain. Let's start with that. So yeah, that is my introduction. I like breaking things, so earlier I used to do it for free, now MATLAB pays me well for it. Uh, I am officially a protocol security engineer at zkSync, and earlier I used to work independently in auditing the code that was written for blockchain protocols. And that's one photo that is clicked 3 months back, which is the only good photo that I have. So that is my overlords, all the C-suite guys from zkSync. So yeah, nice guys. What is a blockchain, right? So let's first discuss why the need of a blockchain was felt in the first place. This is easy. Can someone answer this? Like whatever you think the answer might be. Like why was blockchain introduced to the world? Any reason? Yeah, sure.
For decentralization.
Why did you need decentralization? Yeah.
We don't want the centers to know our data.
We don't want?
Those centers to know our data.
Okay. That's not wrong. But what was the genesis of it? Like, what was so bad that we did not want centralization at all? And by the way, just don't take this as a very formal session. Just take it as a Q&A, happy friends talking along. So let's start off with a few incidents that happened in your time, in my time. I'm old, by the way. So, yeah. So 2007 to 2008 financial crisis. Have you guys heard of that? The housing bubble collapse in the US? Yeah? So please try and also read the small snippet that is there. And go to the third line. What does it say? That it says that excessive risk taking by global financial institutions. That was a key reason for the collapse. And by the way, this led to billions of dollars of losses in the stock markets across the world, millions of people losing their jobs, all bad stuff. Okay. Harshad Mehta scam of 1992. How is it relevant? I don't know. Let's see. So, right. So if you see the highlighted part, you will see that SBI, he was able to get forged checks signed by corrupt officials. So that means some people in the SBI colluded with a guy and gave false guarantees that the check holds. Basically, if I give you a check signed by someone from the bank, that means that they are guaranteeing that I have 100 rupees or whatever rupees the value for the check is. But in this case, they were forged. Similarly, Yes Bank had a scam where the public's money was used to buy very high risk securities without their consent. And Nirav Modi scam, again, same thing happened. This guy got in touch with few of the key bank members at Punjab National Bank, and then he had a scam worth of 14,000 crores. Like, I don't even know how many zeros that is, but yeah. So very recently, not very, last year there was a news that Canadian truck drivers have protested against the government, saying that they do not want certain restrictions on themselves regarding COVID vaccines and whatnot. And the action that the Canadian government took was freezing their bank accounts. Okay. So, does anyone notice a recurring theme in all the incidents listed right now? Does someone see any common link between all these different scams? Yeah. Yeah, please.
Very few individuals have so much power that they can control lives of people.
That's a good one. Yes. Anyone else? Please don't look so sad. Be a little happy, everyone. Okay. So here are a few common points amongst all these incidents that we noticed. So all these scams were facilitated by a few key people at positions of privilege. That is centralization of power. So basically, a lot of money, how it was being used, what it was being used for, was on the whims and fancies of very few people, or even one person in some cases. They were able to pull it off mostly because there was no transparency around the functioning of these financial institutions. So right now, your interaction with the bank would be very straightforward. You go deposit some money in the bank. Sometimes you take out few bucks from the ATM. Sometimes you transfer it, and that's it, right? But if you start interacting with the banks on a deeper level, you'll see that they have a lot of black boxes. They do not really disclose how they qualify someone for a loan, how they do not qualify someone for a loan, how they stop your international transactions for some reason, whatever or whatever. So the ways the banks operate, it's very non-transparent. It's a black box. The entire traditional financial system, including the banks, run on trust, and that trust or entrusted power was abused. So, can someone tell me the money that banks give out as loans? Where do they get that money from? From?
From the money we deposit in the bank.
Exactly. So the money that you deposit, that you give to the bank, you see in your mobile banking application that hey, you have like 10 lakhs rupees in your account. That may not actually be present with the bank because that is the money that they use to lend out, and they have to do that if they need to take out some profits, be profitable organization, so on and so forth. But they can get extremely risky with this and give out a huge amount of loan to very risky businesses and repeat offenders and people who have had failed businesses in the past. So you are trusting the bank that they will lend out your money to good people. Is that point clear? Like why you are trusting the bank? Because they will lend out your money. There is no question about it. Who they lend out to, what is their practices around assessing the risk, you're trusting them with it. So don't trust a bank based on their like brand ambassador being Kiara Advani or something. Just look at their risk mitigation strategies. And almost always, the money that is siphoned off, 15,000 crores, 14,000 crores, so on and so forth, whose money is that at the end of the day? Like, where did they get it from? It was always the retail investors, people who had put in money in some simple instrument such as FD or just basically simply deposited it in a savings account. They were the ones who were getting stabbed in the back all the time, because in 2008 financial crisis, people had deposited money in their bank account and they were not able to withdraw their own money from their bank accounts, which is something so bad, I think, because you used to think that, hey, look, I have this much balance, and when you go to the bank, a bank is asking you like, why do you want that money? It's mine. Anyway, so to sum it up, all the incidents that you saw right now, it happened due to either centralization of power and money, along with abuse of trust. Is that clear right now? Like, why did all these scams happen? Like, what was the root cause of it? That centralization of power, like the MD of Yes Bank could control how Yes Bank spent thousands of crores, and abuse of trust. So people had trusted the Yes Bank to be able to buy good securities, good bank FDs, whatever, and he spent it on like crazy missions and not so profitable, not so risk-free businesses. So that's how the scams came about. And this is what necessitated a financial system which could combat everything wrong with the current system. And the answer was blockchain. So that is why, from an idealistic standpoint, from a ideology standpoint, blockchain came about. Up till now, does anybody have any question? Like, why was blockchain needed in the first place? All cool? All clear? Nice. So, what is Bitcoin? So we'll talk about Bitcoin because blockchain came into existence before Bitcoin, but Bitcoin is the first blockchain of any significance. It's the first one to gain any popularity. So everyone who is not at all familiar with blockchain, please check this out. And who is a lot familiar with blockchain, just don't mind all the obvious gaps in my presentation. Okay? So I'll try to explain it from a very ground up perspective, and I know this is very ground up because I've explained this the same way to my mother, and she understands how Bitcoin works. So I think you're smarter than her, and you'll be able to grab it. So a few key features of Bitcoin. Bitcoin was the first blockchain that gained popularity, that's fine. So the definition of blockchain is that it's simply a chain of blocks. Any doubts? What's a blockchain? Blockchain is quite literally blocks that are joined together by chain. That's it. Is that clear? Right? Okay, let's go ahead. The most fundamental concept of a blockchain is states. You can think of states as the balance of each user of the blockchain. Okay? So if blockchain is a financial system, assuming it is, and there would be users, and users would have some kind of balance, and that balance is the state. User state is user A has 10 Satoshi or 10 Bitcoin or whatever. That is the state of that user. And if the chain has 5 users, then the combined state of those 5 users is the state of the chain. Is that making sense? Okay, so the most fundamental concept of blockchain is states. And states is basically what is the data related to each party that is participating in the blockchain. Now the next question is balance of each user. Balance of what? Right? Well, just like countries have different currencies, the medium of value exchange in the world of Bitcoin is a currency called Bitcoin. Surprise. So just imagine that if you were playing a game with your friends, okay? Or like it was Diwali night and you were at your hostel and you wanted to gamble, not with real money. You bought in Monopoly money. So that signified money, and the value of exchange was not actual money in the fiat sense, but something that represented a medium of value, right? A big Monopoly note represents more value than a small Monopoly note. Is that making sense? So that similarly, in the world of Bitcoin, the actual thing, if you have 1 Bitcoin, that has less value than 10 Bitcoins. And how many Bitcoin you have is the balance that you have, and the balance is the state. Is that clear? Okay. And since we do not want any censorship on our blockchain, anyone can join our blockchain as a user. Uh, Banks can disqualify you for loans. Banks can shut down your accounts if you are doing some suspicious stuff. But we wanted to counter that. And to counter that, we wanted our system, our alternative financial system, to be censorship resistant. And therefore, anyone can join blockchain, the Bitcoin blockchain, as a user. So up till now, okay. So now you must have also heard that blockchain is a distributed ledger. Like this is the definition you must have heard everywhere, right? It's a distributed ledger. Okay, let's talk about what that means. Anyway, so in this page, is there any doubt? No? Cool. Yeah, please.
States, could you please explain once?
Sure. Assuming your bank balance account is X, okay? The one sitting beside you, his bank balance is Y. The one beside him, Z. So that means your state right now at what, 5:50 p.m. is X, his is Y, his is Z. And if we take the state of the entire room, like what is the bank balance of the entire rooms individually at this time, then that is the state of the entire room. Similarly, how much Bitcoin does each person have on the blockchain at any given instance of time? The sum of that is the state of the blockchain. Okay? And I can switch languages if you want: Hindi, English, Tamil, Telugu, Malayalam, Punjabi, whatever. So, part 2. What was the last point in the last slide? Distributed ledger, right? What is a ledger, by the way? Just so that there is no language barrier. What is a ledger?
Record of transactions.
Right. So whenever you go to a grocery shop, they have a khata book, Bahi khata, where they write what was sold for how much. That is a ledger. So if we say that Bitcoin is a distributed ledger, what does that ledger keep a score of? Like what is it accounting for? Okay. Well, I don't think you guessed. Okay, whatever. The distributed ledger's only job is to maintain the balance of each user that uses our chain. That is, maintain the state of the chain. Okay. Now let's recap a little. Blockchain is a सबसे पहले chain of blocks. Okay. And the most fundamental property of that blockchain is states. Okay, all right. And now you also say that blockchain is a distributed ledger. Then the ledger must be accounting for something. What is it accounting for? States. Awesome. That's very nice. Again, you remember that it's a chain of blocks. Well, what does these blocks consist of? This someone can tell me. The chain of blocks, what is in that block? Sorry? What are transactions? Huh? State?
Change in state.
Change in state?
Yes.
Okay. All of you are dangerously close, but she's right. It contains transactions. Let me tell you why. These blocks consist of transactions along with other crypto stuff that you can leave out right now. That's the job of those guys, how to tell you like what the things inside actually are. But mostly, we'll say that the blocks have transactions. Now transactions is the new term, okay? Let's define that. So transactions are the only way to change the state of the chain. That's what he said. That is, if user A had a balance of 5 Bitcoin and user B had a balance of 10 Bitcoin, and both user A's and user B's state make up the state of the chain, which I think is clear by now. So if now user A decided to send one of his Bitcoin to user B, that changes the balance of both the users and hence the state of the chain. So if user A decided to send one Bitcoin to user B, then the balance of user A went down by 1 Bitcoin and the balance of user B went up by 1 Bitcoin. Is that making sense? That means if there are only 2 users on the chain, then the state of the chain also changed. Okay. And how can you change the state of a chain? Via transactions. Okay. So now tell me, what does this chain of blocks, these blocks consist of? Transactions. So just imagine you have a backend system, MySQL, whatever, in a bank. Okay. What does the bank take care of? Like if you have some money in an account and you transfer it to someone, it notes that, right? Hey, you transferred this amount of money to so and so, but that's behind their ID password and their pathetic IT security services. But here, since this is a public, okay, let's not come to that. But here, it's again a blockchain, so you need to be able to account for your money, where did it go and where did it not go. So the transactions, if you just trace all the transactions related to your money, you can see where is your money to the last Satoshi. Last Satoshi is like the paisa, like 1 rupee is made up of paise. Similarly, 1 Bitcoin is made up of Satoshi. Satoshi is a unit of Bitcoin. So, up till now, is there any doubt? Like, do you guys understand what states are, what the blocks consist of, and why do they consist of transactions? Because since that's the only thing that can change the state of the blockchain, you need to have that to make sure that all the changes that were made into the blockchain, you can see them. That's why you don't have any private thing here. Like you can't really sell the money of the public to some Nirav Modi and just run away, because everything you do with the money, we can see from the blocks. Is that clear? Okay, nice. So that doesn't sound very revolutionary, does it? What's the real difference? It's like saying that if we keep on distributing money amongst ourselves and we just write on the board that who gave money to whom and how much, it's almost like Bitcoin. So what else can it do? Well, remember how a lack of transparency was the biggest critical component in putting off all the earlier scams? Nirav Modi being able to collude with a PNB bank agent, Harshad Mehta being able to collude with an SBI bank agent. That was only possible because public could not have access to what the backroom deals were. Blockchain changes that. How? Well, all the information that is stored in any of the blocks of the blockchain is publicly accessible. Now, is it all making sense to you? That since the flow of the money, that is the transactions, which is stored in blocks, and that is forming the blockchain, if that is publicly accessible, then there is no way to hide your wrong deeds, and everything that you do with the money is publicly accessible. That means you can track down the movement of money across different parties, that is users of the blockchain, down to the last Satoshi. Okay. So I think that was clear, right? The public distributed ledger thing. You understand what the ledger does, you understand why it is public, and you understand ledger, it's a khata book. Okay. So that's cool, but how can I believe that the data I queried is indeed correct? So how do you know that the data being put inside of the blocks, the transactions, they themselves are correct? Can someone tell me that?
Because it cannot be changed.
Why?
It changes the state.
Huh?
Because it changes the state.
Right. So if I said, if user A sent user B one Bitcoin, and instead of inputting that information into the block, how is it that nobody can put 2 Bitcoins were sent from A to B on the block? Like what? Yeah. Must be the user B that? No, not really. Users are users. They are not running the chain. Okay, they're just interacting with the chain. Okay. All of you are very close. So let's get on to the next concept of blockchains. So, well, the guarantee of accounting correctness is generated via 2 layers. POW, which is prisoners of war, proof of work, sorry, and cryptography. So, can someone tell me what proof of work is? Can someone tell me what mining and miners are? Any like don't worry about the answers being wrong. Just tell me whatever you think about it. Yeah.
They include what goes into the blockchain.
They what?
They include what goes into the blockchains.
Bingo, correct. That's nice. That's very nice. That is one of the key functions of what the miners do. Anything else? Yeah.
I had a different question that if users are not running the chain, then
Mhm.
who is running it?
Miners. I'll come to that. I'll come to that. Yeah. Guy with the headphone, were you saying something? Okay. So, what are miners? Good question. Have you been to a coal field? Sorry. Very simply put, these are the entities that run the blockchain. That is, they are the one that collect all the transactions, convert them into a block, account for the state changes, and propose those blocks to be added to the blockchain. Okay. So if I tell you that the blockchain is a chain of blocks, that means each block must have a specific capacity, right? Let's say, for example, a block can have 10 transactions, okay? And in the time a miner can make a block, suppose 20 people did some transactions, okay? So who decides which 10 transactions would go in the block? And in which order? And which one of them are valid? Who decides that? Who takes care of that? It's the miners. Miners are the one that takes all of your transactions from the mempool. Mempool is the waiting area for the transactions where they are waiting to be included into the blockchain. Okay. So the miners are the one that pick up all the transactions that they want to create the block. They check them whether those transactions are indeed valid or not. Because if I am a user A, which with 5 Bitcoin, and I create a transaction that, hey, I've sent 6 Bitcoin to user B, that should not go through, right? The miner is the one that tells that, hey, this is a BS transaction, this cannot go through. So, anyone can create fraudulent transactions, claiming state changes that are not actually feasible or practical with the rules of the blockchain. The miners are the one that act as a shield and say that, hey, this transaction is valid and this is not, so you can just get out. And this is what we include in the block. And this might look like a bit of centralization of power, that hey, why does the miner have the power to include and exclude transactions from a block? Well, yes, it is. And the solution to that is anyone can be a miner. So if anyone can be a miner, no one is the owner. No. Suppose even if USA today decides that, hey, we will not include Bitcoin transactions coming out of Chinese IP, okay, they can do that. And suppose even if there is one miner in the entire blockchain network that is from China and says that, hey, I'll include it, nobody can say no to that, because if they are valid transactions and they have included in a block, then the blockchain will include transactions from China as well. So that means you are fighting against centralization of power by giving access to anyone and everyone. This is technically called permissionlessness, and that is one of the key features of Bitcoin. So anyway, any doubts in these 4 points? What are yeah? No. So what happens is that when a miner puts in a transaction in a block, they propose those blocks. They do not add it, they propose those blocks, okay? And once you have proposed a block, there is something called the consensus mechanism, where all the miners and the network participants have a look at the block that you have created, and they validate it that, hey, if you have done this correctly or not. And only after the entire network has validated it, then does the block created by the particular miner goes into the blockchain. Is that making sense? Okay. So the validation part, how do they validate this stuff? That is done via cryptography. Point 2. So I mean, like, it's very basic cryptography in the sense that if you have one block, you will do a hash of all the states, and include that hash in the next block. Okay, and then you will do a hash of that hash and the block and the state of the second block, and you include the complete hash in the third block. And that's how what happens is that if any of the miners tries to change a state in a previous block, the hash would not match with the rest of the network participants' hash value. So they'll say that, hey, this is an invalid hash, you have done something invalid, we won't accept this block. Everyone understands what a hash function is? Sorry? Okay, hash function, not hash. Okay. So hash function is something that can take in arbitrary amounts of data as an input, and it has the power of giving out an fixed amount of encrypted data. In the sense that if you were to use any particular hashing algorithm such as SHA-256, SHA-3, RSA, whatever, and you input like your name, then an encrypted version of that name would come. And the cool thing about hash function is that you cannot decrypt it back to your name. Okay, these are only one-way functions. Does anyone else have problems understanding what a hash is? Hash function? Please feel free. This is like, I'm going super low and I can also go like a little deeper. There's no issues. Okay. So yeah, this is what the Bitcoin is all about. Yeah, and as someone hinted towards, like how can we be sure of the integrity of the miners? We do that via some basic cryptography for verification and competition with the rest of the miners and the requirements to solve a small mathematical problem. So it's basically like you are required to do something, okay? And you have 20 different miners, 20 different people competing to do the same thing, okay? So they are very eager to find any kind of mistakes that you have done in the work, okay? So they'll be first one to point out, hey, this is wrong, this is an invalid transaction, let me do it, okay? So that explains the competition among the miners to do the job of proposing the blocks. And also, they have to satisfy the cryptography thing that I talked about, that the hash of the last block should match the input of the next block. And yeah, there is some random function that is generated by the Bitcoin protocol as well, and you have to do a calculation to be able to be eligible for mining the next block. And this calculation thing, the mathematical problem, this is where that thing that you hear comes from, like mining farms in China, taking up a lot of power, doing a lot of electricity, computation, stuff like that. So all the computation goes into solving this particular mathematical problem, because if you are the first one to solve it, you are the one who proposed the blocks on the blockchain. Okay? So a blockchain is a chain of blocks. Those blocks contain transactions, and which transactions would be in that block and who validates those transactions are the miners. And these miners are in competition with each other to be able to propose the block first. Why? Third point. They are in competition with each other and they want to run the network because the network rewards the miners in the local currency of the ecosystem, Bitcoin. So just let's go back to the Monopoly example. So if you are playing Monopoly and you win or you do something good or you want to be rewarded in some way, what is the way to reward you? Monopoly money, right? So this Bitcoin world is a world of its own. And if you are doing a service there, because it takes significant compute energy to do it, then you are rewarded in terms of Bitcoin. So these are called the miner rewards. You must have heard of that. I'm earning money via mining. You must have heard of a couple of your friends or old people, I think. This is what it is. Mining is proposing the new blocks, and if you propose a new block, you are helping keep a chain alive, and that chain rewards you for that. That's it. Okay. Uh, okay, and the chain part, like the one thing connecting all the blocks, is actually a hash of all the previous blocks of the blockchain. And if a miner tried doing any changes in an earlier block, the network of miners would immediately be able to tell, since their version of the blockchain state's hash would be different. So this is the small cryptography part in Bitcoin, which is very simple if you look at it. If it looks confusing right now, it's simply because of English, not because of the maths, trust me. And all these things, all the last 5 slides that we have seen, that is what makes Bitcoin a global, permissionless, decentralized, immutable ledger to track the flow of money. Any doubts so far? I mean, you would have it, but like, if something is there which makes absolute no sense or goes against what you were thinking, just let me know. Yeah.
How does Bitcoin get its value in real world? If a miner is rewarded a Bitcoin, like that would be in this hypothetical thing. How will he gain its value in the real world?
I'm super proud of myself because I expected that next question. So this is an optional side quest. If you want me to dive into it, I can. I can give you a small explanation. Or do you really want to know that? Yes? Sure? Okay, let me give you a small explanation for that. Coming back to your Monopoly money, okay? So, Monopoly, I mean, you are in that room, okay? You are playing Monopoly. Let's consider that room as your own small world, okay? That Monopoly money has no value outside of the room. Similarly, the network is running, Bitcoin are the rewards, Bitcoin is what you're transferring to each other, Bitcoin has no value, okay? But what if someone on the outside says that, I'm talking about your Monopoly example. Someone from the next wing or the next room comes in and say that, hey, I also want to play Monopoly with you. And you say, I can let you play Monopoly with me and I can give you this stack of Monopoly cash if you give me 100 rupees. Does that make sense? So an outside player wants to join your network or your room and you want to give them your imaginary money, but why would you give them for free? If there is enough demand, you can increase the value that you ask for to get that imaginary money. Just now, like, one guy came. Imagine if NIFT Delhi came. Okay, not NIFT Delhi. If like the Triple Delhi guys came, like a lot of people came. You can ask for like 1,000 rupees for 1 rupee of Monopoly money, right? So the demand to be included in your room is what is creating the value for the imaginary things that you're playing with. Okay? For example, think about the INR, Indian rupees. Why does it have any value whatsoever? By the way, who knows that the fiat currencies, dollars and Indian rupees, are backed by gold? Do you don't know that? Seriously?
Like I know that we're not into data.
Uh-huh. Acha, galat jante ho. So the gold standard was done away with in 1980s, and since then the fiat currency have no backing whatsoever. So you would have read in the notes that I promised to pay the bearer 10 rupees and whatsoever. So that note, its value is simply the promise of the government of India. And can someone tell me when did the government of India violated that promise? Any instance of that? Exactly. If I have an old 500 rupees which says with the sign of the governor that, hey, whoever is the bearer of this note, I promised to give him a value worth of like 500 rupees, right? But you won't get it. That is demonetization. Similarly, Bitcoin is backed by nothing. That's true. Like similarly, like gold is backed by nothing, whatever. But if people outside of the network feel that this network is something that they want to be a part of, they want to invest in, without running the nodes. One way of getting your hands on Bitcoin is you become a miner, You run the nodes, you propose blocks, you get rewarded in Bitcoin, that's cool. But if you are a college student or if you have something else going on in your life and you simply want exposure to Bitcoin, you want Bitcoin because you think that people will eventually start believing in the system and they will come into it, then you simply buy it off a miner who have been rewarded in Bitcoin. And whatever the demand is for that particular Bitcoin from the miner determines the price. And that determining of the price, the matching of the buyer and seller is what happens on CEX, centralized exchanges. So any exchange that you know of, like you won't know about DEXs, so any exchange that you know of, KuCoin, Binance, Kraken, Coinbase, their primary function is determining the value of a cryptocurrency. How do they do that? They tell you that, hey, this is a Bitcoin, this Bitcoin comes from the reward that is given out to a network called Bitcoin. And if you want it, tell me how much you're willing to give me. And once they have enough volume, they determine a particular market price for one Bitcoin. Is that making sense? Is that making sense? Okay, let's go back to your monopoly example. One guy came, he wanted to play with you, and you asked, like, I'll give you this stack of monopoly money, give me 100 rupees. Okay. Next day, instead of one guy, 5 guys come in. And then you say that, hey, I only have like 3 decks, I can't give it to 5 guys. So whoever pays me 150 rupees, I'll give it to them. So that means the demand increased the price, right? Similarly, if like after a year, like you are back to one guy again, that means the price has to go down to meet the demand, and the demand, since it has got down, the price also has gone down. And that's why Bitcoin is very volatile, because there is no particular demand / supply shock absorbent for it. So it basically depends on the sentiments, like when people think that Bitcoin is the future and it will do well, and people are starting to shout about it from the rooftops, they want to buy in, creating a lot of demand, which increases the value of Bitcoin, and when it is not, the value of Bitcoin drops. There is another deeper concept here, which is, let me give you a prelude, I won't dive into it. When I say that the value of Bitcoin increases or drops, I mean that in the USD terms, INR terms, okay? And that is assuming that USD or INR is static. But is USD or INR static? Because I remember a time when I used to buy a bread for 10 rupees, now it's for 40 rupees. A loaf of bread. I mean a pack of bread. So is the value of rupee constant? No. Then how can you say that the Bitcoin is volatile if you're comparing it against INR or USD? So that's something like, that's why I didn't really want to go deep into it, because that goes heavily into the economic side of things, on which I'm not an expert. But yeah, happy to chat if you want to continue afterwards. So, up till now, does anyone have any questions? People who are not familiar with blockchain at all, is something looking good, something making sense? You have some understanding of what blockchain is, why blockchain exists, what's the basic mechanism of how it works? Nice. So, you must have heard of Ethereum, right? And zkSync is an Ethereum L2 validity rollup. And why did I start with Bitcoin if I am from zkSync? So the reason is, Ethereum is built on the shoulders of a giant, and that giant is Bitcoin. So Ethereum is the next evolution of Bitcoin. That does not mean that Bitcoin is outdated. That means that this has given an extra utility to what Bitcoin can do. Okay. So now you have money that is not controlled by a centralized authority, cannot be trifled with, safe, secure, and transparent. So assuming you consider Bitcoin as money, then that money is not controlled by anyone, and it is sound, it's safe, because you know it's cryptographically guaranteed, that it's not been trifled with, it's exactly how it is supposed to be. It's not here and there are no scams going on. So that's good, but that system has quite a limited utility, right? Well, you can use a Bitcoin blockchain to send money and receive money, but that's it. You cannot do anything else with it. So, I mean, it's cool that you can transfer money from one to another, but that's not doing much. So, what happened next? When people realized that, hey, Bitcoin offered a new future, a new financial future, a new alternate financial universe. That's not just transferring money. There are stocks, options, trading, derivatives, bonds, debentures, stuff like that. How do we get that? So Vitalik enters the chat along with the other co-founders, but yeah, this was for dramatic purposes. So Vitalik, along with the other co-founders of Ethereum, come up with the idea of being able to run logic on the blockchain. So right now, the Bitcoin blockchain that you all knew of was able to account for state changes, right? If I give money to someone, my balance/account balance goes down, and if the person receives money, their state changes and they increase their balance. But what if we can do those account changes based on some logic? As we saw earlier, blockchain is just a chain of blocks, and each block mainly stores all the transactions that happen in a given time frame. And by given time frame, I mean like a new block is produced in Ethereum every 12 seconds, and it captures the activities that happened on the blockchain in 12 seconds. So, and also remember that transactions are the only way that you can create any change. So, if we could run logic on the blockchain and the transactions that are generated using that logic are captured in the blocks of the blockchain, then we can prove that anything that happened on the blockchain happened via pre-written, publicly available, and immutable logic. Is this train of logic making sense, train of thought making sense? Like Bitcoin was able to give you how state changes and was able to account for it, and it was able to make sure that nothing was wrong with it. Now, if you were able to make those same state changes via some logic, like for example, you created a logic on the smart contract. By the way, logic is written in smart contracts in Ethereum. So you created a logic that, hey, if on the 15th of this month, the temperature goes beyond 40 degrees centigrade, then transfer 1 Bitcoin from my account to B's account. Okay, a state change is happening, a balance change is happening, but that is happening via a sophisticated logic. Is that making sense? Now, a state change is happening and a transaction is happening via logic. That means, okay. That means if you can mimic the logic behind the current financial vehicles and run that logic on the blockchain, that means you have just created a financial vehicle that behaves exactly like the financial systems you knew. But those financial systems are completely immutable, censorship resistant, fair, and so on. So basically, just imagine you wanted a fair bank. You wanted a bank that did not cheat you. You wanted a bank that was fair to everyone else, had no permission systems and whatever. So you mimic the behavior of the bank on the blockchain. Remember that blockchain can now run logic. So you created logic that mimics, that basically does the same behavior as the bank, and that's now on blockchain. And since blockchain was supposed to be immutable, you cannot change the logic that is once set in the blockchain. That means that your bank that is now on chain will run according to a code that you have written. Is that making sense? This thing? Anyone? Okay. All in all, what this means was Ethereum ushered in a massive value unlock. Now on Ethereum, on Bitcoin was just able to send and receive money. On Ethereum, you have the ability to create currency exchange protocols, lending borrowing protocols, futures and options protocols, perpetual futures protocol, anything that you can do in the traditional finance world, you can do that with the same, you can do the same on blockchain now. And why was blockchain important in the first place? Because of all the scams we saw, and this is what makes it all fair for you guys. So, okay. Any doubts so far in like how Bitcoin functions and how Ethereum functions and what's the difference between the two? Okay. Let's talk very quickly about the blockchain trilemma and scalability. Okay, so this is the blockchain trilemma. So this blockchain trilemma says that if you are designing a blockchain, you can only get 2 out of these 3 things. So the things that are written here, if you cannot read, it's scalability, security, and decentralization. So what that means is that if you are designing a blockchain and you wanted it to be secure and decentralized, then you have to give up on scalability. Similarly, if you designed a blockchain with scalability and security in mind, you will have to give up on decentralization. So this was the particular blockchain trilemma. And since Ethereum and Bitcoin were based on the ethos of decentralization and security, they had to give up on scalability. So what does scalability basically means? Scalability means that I told you that each block on Ethereum is created in a 12-second interval, and those blocks have a limit of how many transactions that they can have. So that means Ethereum has a transaction per second limit. Okay, how many transactions can Ethereum process in a second? Which is around 12 to 15. And if you compare that to something like Visa, it has a transaction processing capability of 24,000 transactions because it is centralized. It does not really care about consensus mechanism, miners and whatnot. It just does what is the fastest. So that was the problem with the blockchain and Ethereum. No, let's not talk about that. This. So if you read the 5th point, it says that we cannot ask everyday users to switch to a different financial vehicle and tech paradigm with way worse throughput than the currently existing system, right? If you are creating the same financial vehicles on blockchain and you are offering way poorer throughput, like way poorer user experience to the users, you cannot ask them to shift to Ethereum, right? Like it does not make sense until they are like some cyberpunks who do not want to share their data and like are already very paranoid. So we have to scale Ethereum, and that is where layers 2 come up. So if you replace the scalability issue with rollups, then that is the thing that solves blockchain trilemma. And now, who was the one telling about how layer 2s work? Yeah, please go again.
Basically, we use week lovely transactions together, and basically they have transaction limits, so week lovely transactions, and then write that on week lovely.
Correct. So there are a lot of details to it, but let's focus on the very fundamentals here. So if this is the blockchain trilemma, and Ethereum is giving you first class security and decentralization, but you want speed, scalability, what would you do? You create a layer 2. A layer 2 is basically like, you can think of it like a separate chain which is created with the only objective to have maximum speed. Okay? Now imagine there is a chain which has maximum speed. It does not really care about security or decentralization. Now that is able to process a lot of transactions in any given in like a very short amount of time. Okay, you can practically run an AWS EC2 instance and say that hey, it's a layer 2, as long as what's the catch here? Like, what's bad with a blockchain that has very high speed but no security and decentralization? What is wrong? Sorry? Yes, correct. like if you have a blockchain that does not have decentralization, they can censor anyone. If they do not have enough security, consensus protocols can get broken. If they are using just one particular physical machine, that can go down, and the network can go down as well. So a layer 2 is a valid layer 2 that gives speed to Ethereum as long as it can prove to Ethereum that the transactions that it did on itself, on the layer 2, were valid, right? So even if I was running a very bad blockchain and it had no security and no decentralization or whatever, but if I can prove to you somehow that hey, all the transactions that I did were fair, transparent, and valid, then that means I'm game, right? I'm good enough. Because if I already have the property of scalability and I can prove the other two, then I have solved the entire trilemma, right? So that's what layer 2s do. Yeah. Now remember how miners or validators in the case of Ethereum maintain the security of the entire blockchain by validating every proposed block and kept on running the system. Like if you think about Ethereum and Bitcoin, it was very decentralized and secure, and that was done via the miners and validators. Well, what if we could create a bad blockchain that is like it has no regards to security and decentralization but very high speed, where the only focus is speed, and then aggregate say 100 of those transactions that happen on the chain into a single Ethereum transaction and post it on L1 Ethereum blockchain. So we did something on the top, whatever. We took a lot of those transactions, aggregated them into a single transaction, and put that on Ethereum. Okay. If our transaction, which is an aggregation of the state changes that happened on our bad blockchain, gets included into an Ethereum block, that would mean that it passed the scrutiny of the Ethereum operators, right? So if I could get my 100 transactions on the bad blockchain gist onto an L1, and the miners of the chain of Bitcoin or Ethereum agree that this is fine, then that means that I have this decentralization and security of L1 as well, right? Of the base layer of settlement. So that was the idea behind rollups. So what we have done here is get speed boost from a bad blockchain and get the security and decentralization guarantees from a good blockchain such as Ethereum. So far so good. Any doubts? Yeah.
So in this part, is there any competition among the miners, like to become miners?
In the layer 2s?
Yeah.
Yeah, so miners only exist when you want to go for a decentralized system. And if you do not care about decentralization, you can have just one person which is proposing all the blocks, including all the blocks, right? And if you have multiple miners, then there has to be time that is required to do the consensus thing, time required to select the miner. That is all slowing down the chain. So in layer 2, all you really give a damn about is processing the transaction as fast as you can. And people say that hey, we'll have decentralization in the future, but I don't know if that's in the roadmap very early or not. So what is a layer 2? No. Again, layer 2 is a bad solution, bad blockchain that has extreme speed and that gets the security and decentralization of L1s via settling the aggregation of its transactions on L2. Yeah, this is the diagram that basically summarizes what that guy told and what rollups are. So you see all those transactions, that is basically the mempool of L2. A lot of those transactions get created into a single block, and that single block is does not seem right. So basically a lot of these blocks should have been also aggregated into a single thing. and that single thing should have been included in layer 1 Ethereum. But like, that's the general idea. And of course, since you are using layer 2s, which has like no requirements for miners, no requirement for decentralization, no requirements for consensus, the cost of running those chains is very low. So the gas fees that you give for getting your transactions through, basically the fees that you have to pay to the miners, that is very less. So you'll see that the fees is in the cents range, like 0.03, like it's 3 cents per transaction. On Ethereum, it has gone up to like $50, $60 on like very normal days. Let this be no issue. Pause this. Okay. So till now, everyone understands what what layer 2 solutions are, what layer 2 rollups are. Okay. Separate chain that takes only speed into account and uses a layer 1 or lower level chain for its decentralization and security. Now, how do we make NL2? When the first discussion started, which was way back, there were two schools of thoughts: optimistic rollup and a zero knowledge rollup. So it is a long thing to discuss how these works, but let me tell you very briefly what are optimistic rollups. So in optimistic rollups, you just assume optimistically that everything that happened on layer 2 is right, and the blockchain processing that they've done is correct. And if you were to find an issue with whatever they have done, you have the ability to create a fraud proof. You can challenge the transactions they have created, the state changing transactions that they have created, and say that, hey, I think that this particular state change is wrong, and I challenge this transaction. And if your challenge is true, then the layer 2 will roll back to an earlier state and do the transaction correctly. So that is how you maintain the correctness of what is happening on L2, which sounds extremely stupid because the challenge period is 7 days, and just imagine that one wrong transaction was challenged on the 7th day, and it took time to figure out if it was actually wrong or not, and if it was actually wrong, then the chain has to revert every state change that it did for the last 7 days to go back to an earlier state where it was correct and do things all over again. So that is how optimistic rollups work. Compared to what zk rollups are, so zk rollups are basically zero knowledge rollups, where zero knowledge means zero knowledge proof. So what is a proof? You can think of proof as a cryptographic entity which can be used to deliver a promise without actually delivering the things that make up that promise. So basically, the very old example that is given to explain what zk is that if you want to prove to someone that, hey, you are like over 21 years of age, you have to give them your Aadhaar card or PAN card or something like that, right? But if you can go into a shop and get a beer bottle, that proves that you're 21 years of age without showing your Aadhaar card. Does that make sense? Like, the only thing that needed to be proven was that you are over 21 years of age, but you did not want to share your Aadhaar number. So to do that, you created an alternative problem, solving which the result would be the same. Like, the implication of solving that problem would be the same as that you are over 21 years of age. So if you can get the beer, that means you would have passed the validation from the beer seller or whatever, and that means that you are over 21 years of age. So imagine doing that proving thing for the entire chain that is running on L2 and sending those proofs on L1. So basically what that means is you are running a chain that is completely focused on speed, and for every transaction you have a proof that this transaction is correct. That basically solves all the problem that optimistic had, that you are assuming things to be correct. Here you have a cryptographic proof that whatever you did is correct. So that is why I believe that zk rollups are much better compared to optimistic rollups, and they provide speed with cryptographic guarantees of the correctness of the execution on L2s. That's nice. Succinctness is leave it. Let this be. Okay. So far, whatever I've explained was the theoretical stuff about what blockchain is, what rollups are, and what the different types of rollups are. Is that fine with you guys? Did you guys understand something? Something? Okay. Okay, cool. Now, are you interested in understanding the maths behind how a zk proof is generated, or yes? Sure. Okay. So I won't be giving you the actual thing on how zk proof is generated, because if I asked at random, like, hey, can you define what a ring and a field is? Can you do that? Okay. Can someone define what a ring and a field is? Not you. Apart from Manoj. Okay. So basically, if you like what you see here, just go back home and take like 1-2 hours of your time and read about abstract algebra. Start from what a set is. Like, you can define what a set is, right? A set. Dude, set. Like collection of elements set. Okay, nice. So if you keep on adding properties to set, you will get monad, and then you'll get a group, and then you get a field and a ring and shit like that. So that is the basic concepts from which we can start to learn about zk proofs. So since that would be long, I'll give you a very short intuition of how zk works. So as I gave you the example of the Aadhaar thing, you are the prover, you want to prove that you are above a certain age, so you do not want to send your Aadhaar number to someone from which they can verify. So you create an alternate problem, that is getting a beer, and the implication of solving that problem is that you are 21 years of age. Fine? That's what's written here in English, which is bad. Can someone explain what the P versus NP problem is? Computation complexity thing. Very good. Carry.
P is something which we can solve any problem in polynomial amount of time.
Exactly.
And NP is something
non-deterministic, which you can verify with polynomial.
Which you can?
Verify in polynomial. So you have a witness and you can solve it. You can check whether it is true or not.
Right. But like verification पे बाद में आते हैं. NP problems basically take exponential time to solve. So O of n square and q की जगह you get e to the power n something, which is not nice. Okay. So and like yeah. So P equals to NP basically is a huge segment of computer science where people want to be able to solve NP problems in this thing P time, like polynomial time. So for example, I'll give you why this is such a big research area. P is equal to NP. By the way, did you understand what the research is about? Researchers want to be able to break down NP problems into P so that it can be solved in polynomial time. Why would you want to do that? Because let me give you an example. Does protein folding make sense to you? Protein folding, suna hai? Okay. So protein folding is what happens when you get cancer. So your cells become intertangled with each other, proteins become intertangled with each other, and solving protein folding is an NP problem. Imagine if you could solve an NP problem, which is the folding of protein in P time, polynomial time, that means you would have cured cancer, just as it is. You would just ingest the protein pattern of a particular person that has cancer into your computer, and computer will tell you in polynomial time how to untangle that and make that person healthy again. So that's the big implications of what P equals to NP can do if we can do it. But the issue with that is it can also break all the encryptions that exist in the world right now. Because encryptions are an NP problem, it's not about hard. And NP problems take exponential time to solve, and that is why your fingerprint lock and your WhatsApp KI2E communication works. Because it's not easy to decipher back what was written from the encrypted form. But if it was converted to a polynomial time problem, it can be. So the biggest threat to cryptography and blockchain and whatever is, I guess, quantum computing and things like this. But let's see, we do have post-quantum safe algorithms. So yeah, problems in P are problems that are easy to solve and easy to verify solutions for. So if you have a problem of sorting a list, can someone tell me what's the complexity of sorting a list? Huh? N square? N log n. ठीक है. Merge. ठीक है. Okay. So whatever she said, it was polynomial time, right? Good. And if you wanted to check that the list that was given out as a result of any sorting algorithm, it was sorted or not, how much time would it take you to verify that? Yes. O of n. Simply iterate the list. Okay. O of n. Just check whether this element is smaller than this or not. That's it. Similarly, finding the index of an entry in a given list, you can do that in O of n time, and you can verify that in O of constant, O of 1 time, because you simply check the particular index on the array. So in the examples above, both computing and verifying the solution can be done in polynomial time. Okay, so if you have solved a problem, so basically you were given a list and you have solved the problem of sorting that list. Now how do you prove that you have sorted the list? You give out a witness to a verifier. A verifier is a person who will verify that you have correctly solved it or not, and the witness, in this case, the answer that you are giving, the proof that you are giving that you have solved it or not, would be the sorted list, right? You'll give them the sorted list, and if the verifier says that, hey, this is a sorted list, then you solved it correctly. But that is giving away the sorted list, right? What if you wanted to prove that you have actually solved a problem without giving away the actual solution, right? And I am being very careful about talking about solving a particular problem and verifying the solved solution, okay? Zero knowledge proofs are not about solving the problems, they are only about verifying the computations done, okay? Let that be very clear. And by the way, that's a huge misconception amongst anyone. Like, I've seen people 2-3 years in the industry and saying that we can do this and that with zk. No, you cannot. Shut up. Problems in, can someone tell me what piece? Okay, no, it's not relevant. Okay, what are NP space problems? It's written. So NP space problems are problems that can be quickly verified but not quickly computed. In the sense, can someone give me an example of this NP problem? Any problem that is not solvable in like polynomial time but can be verified in polynomial time. Problem that cannot be solved easily but can be verified very easily. Correct? Sudoku? If I give you a Sudoku puzzle, can you solve that in polynomial time? Can you give me exact time in which you will solve it? No, right? Because If I have the same exact amount of numbers in two different puzzles, it will take you different times to solve it, right? So that means it's not dependent of n of anything. But if I give you a solved Sudoku puzzle, it will take you polynomial time to figure it out, because all you have to do is check that each square has 1 to 9, each line has 1 to 9, each like vertical and horizontal line has 1 to 9. So that is example of an NP problem that you have a Sudoku puzzle. Okay, and what did you say? Can you repeat that again?
Satisfied.
Okay. Can anyone tell me what the satisfiability problem is? I mean, I don't know why we go for such fancy terms, but it's basically finding an assignment to a Boolean formula that results in true, verifying the proposed assignment causes the formula to result in true. So if I had like 3-4 variables x1, x2, x3, and I did x1 and x3 NAND x2 or whole bracket negative x2 whatever, and if you can give me the values of x1, x2, x3 such that it results in true, that means you have the solution correctly done, right? I can verify it simply by putting in the values, but you cannot find the answer in polynomial time. Like, that's a very hard problem to solve. It's so hard that we have something called the SAT, like satisfiability theorem problem solvers, SAT solvers. So it is hard, by the way, like you cannot solve it. There is no fixed algorithm to solve it. So what ties P and NP solutions problems together is that they can be verified in a polynomial time. Okay? Problems can be very hard to solve, but verification of them can be done in polynomial time. P and NP problem. There is another problem that is even outside of this range, which is called the P space problem. Those are problems that cannot be computed easily and also cannot be verified easily. Can someone give me an example of that? Just think of it. And instead of polynomial, think कि ऐसी कौन सी problem है which is very hard to solve, and even solve हो जाए, then it is also very hard to verify it. Think of anything goes. Problem is a problem as long as you can model it into a computer. Okay, I'll give you a classic example. So, chess engines होते हैं ना? One of the problems that they solve is what is the next most optimum move to make that puts you in position to win. Okay? So if I say that the problem is what is the next most optimum move in a chess match, that is a P-space problem, because solving that is of course not easy. It's not taking you like P time. But even if I tell you the solution that hey, move this pawn here, you move that rook there, even after that you cannot tell if that's the most optimum move, because you don't know that you'll win or not, and like how close you'll be to winning or not. So that's a P-space problem. So अगर उसको छोड़ दें, then we have P and NP problems, and the common thing amongst them is that you can solve them in different amounts of time, but you can verify them in polynomial time. So if we could create a different model of the problem, okay, a different model of the problem, that would be very helpful. And when I say a different model of the problem, why do I say that? Because, again, let's go back to the Aadhaar example. The problem was, how do I prove that I'm 21 years of age or above, and I do not want to send you my Aadhaar number, right? So I created my model of the problem, that hey, if the end goal is to verify that I'm 21 years of age, I'll just go and show that I can buy a bottle of beer, right? Because to buy a bottle of beer, you have to be 21 years of age or above. So here, if we can convert P and NP's problems into a different type of problem, such that they can be verified in P time, that would be great. So verifying a solution to a problem in NP or P can be accomplished by verifying a solution to a Boolean formula that models the problem. A Boolean formula that models the problem is what? that guy just told us? Exactly. So if you can convert any given problem into a Boolean formula, right? And if someone can give you the answer to that Boolean formula, then you can verifiably say that that person had actually solved the problem, because it took me like O of n time to verify it. I don't know how much time it took him, but it's the correct solution, because without the correct solution you cannot have given the solution to me in like correct time, like less time. So suppose we have a bunch of Boolean variables x1, x2, x3, x4 and a Boolean formula such as out equals to itna. Now if someone provides me a witness vector of x1, x2, x3, x4 values such that if I put them here, out is equal to true, then that is my verification that this is indeed a correct solution, right? Whoever has supplied that witness vector to me had solved the problem. Which problem? Whatever problem this problem is a model for. Remember, this is not the actual problem. This is a modeling of our original problem that we have made, so that we can verify that they have done the solution without actually knowing their solution. Right? Okay. Okay. Now let's understand this with an example. Images, I don't know how to bring after animations, so ignore that. The problem again is you have a given list and you need to verify whether that list is sorted or not. Okay? So all problems in P and NP can be verified by transforming them into Boolean formulas and showing a solution for the formula. Satisfiability problem. Let's consider an example where we need to verify if a given list is sorted or not. So we have array, which is the witness vector, that is the sorted list. Now we want to verify whether that is sorted or not. So by the way, this can be done in O of n time, like immediately, but I'm just showing you how to model a problem into a Boolean satisfiability problem. So consider one bit binary number A and B. So whatever number you have got, like suppose you have got like 4, that is 1 0, okay, 8 1 0 0. Similarly, you have got any number, doesn't matter, those are all breakable into bits. So let's try to see how do we compare bits. So if we have one bit binary numbers A and B, and we created a truth table for A greater than B, then if A and B both are 0, A greater than B is false. A is 0, B is 1, A greater than B is false. A is 1, B is 0, then it is true. But if A and B both are 1, then A greater than B is 0. This truth table makes sense? Any issues? No? Pretty simple? Cool. Okay, again, ignore the picture. So, the column A greater than B can be modeled with the expression A and not B, which returns true in the only row where A is greater than 1. So, this truth table you see, 0 0 1 0, this can be mimicked if you do A and not B. So basically you got the comparison A greater than B into a Boolean formula, A and not B. Okay? Let's now look ahead. Now consider a table that expresses A equals to B. This is the table. Whenever A and B are equal to either 0 0 or 1 1, this is A equals to B is true. Okay? What is this a direct circuit for? The direct truth table for? Huh? Maybe just like, have you guys heard of XOR?
Yes, sir.
ठीक है, ये XOR का उल्टा लग रहा है? Cool. Okay, so small caveat here, we won't use XOR directly, but XOR का representation in and OR, we'll use that. So the column A equals to B can be modeled with the expression A and B or not A or B, which is how you represent XOR ka negation. Okay. So this returns true when A equals to B, B equals to 1 and whatever. So now you see that if you are given one bit numbers A and B, you have the Boolean formula to check whether A is greater than B or not, or A is equal to B or not. Is that fine? The expression for one bit numbers, a greater than b is equal to a and not b, and a equals to b is this thing. So suppose you start from both numbers leftmost significant bit. So you are given two numbers and you convert them into binary. You start comparing those numbers from the leftmost significant bit, okay? And you move towards the rightmost least significant bit, and the first bit where those two bits differ would give you which number is larger or smaller. Does that make sense? If the numbers are in binary, a and b are both in binary, and you are checking from the most significant base to the least significant bit, wherever the numbers are different, like if it is 1 1 0 0 0 0 1 1 0 0, then it's all equal. But as soon as it is 0 1, then that means there is a discrepancy between the two numbers. Then there is a difference between the two numbers, and there, if p has a value of 1 at that bit and q has a value of 0, p is greater than 0, greater than equal to 0. P and q are the numbers, by the way. If p is equal to q, then all the bits are equal. P is equal to q also means that p greater than or equal to q is true. If p is less than q, then we'll detect that on the first bit where q is 1 and p is 0. But does that make sense? How can we compare the bits going from MSB to LSB, showing that which particular number is smaller or lesser? Is that clear? We first decided how to determine if a number is smaller or greater using one bit. Then we converted any given number into bits, and we did that particular algorithm over all the bits. Okay? Suppose without the loss of generality that we have the number, we number the bits in p and q. Okay? So let's assume that the number that we have, p and q, are both 4 bits number, and those bits are represented as p1 to p4 and q1 to q4. Then p greater than equal to q must be true if these happens. The most significant bit of p4 is greater than q4, or p4 is equal to q4 and p3 is equal to q3, or the first two bits are same and p2 is larger, or the first three bits are same and p1 is smaller than greater than q1, or both of them are equal. So this is what stands for p greater than equal to q. We can combine the bullet points into a single equation. Just combine them using an OR. And recall our Boolean expression that model one bit equality and comparison. It was this, right? We can substitute the expression for a greater than b and a equal to b formula in the equation above. So we take this formula 3a and b and put that in 2a b c d. Is that making sense? Okay. Once you do that, you have a Boolean formula for checking if a number p is greater than or equal to q or not. If someone can give me a value of p1, p2, p3, p4 and q1, q2, q3, q4 such that it satisfies this particular Boolean expression, then that means that they have actually solved p greater than being equal to q. And we have done this for p greater than equal to q. How do we do that for a list? You basically compare the numbers of a fixed size. We would simply repeat the comparison expression, like whatever the list is, we'll take two numbers from the list going from left side to right side and repeat this comparison expression for each pair of the elements and add all the results together. If any of the results were 0, which means that p was lesser than q, then one of those results would be 0 and the AND of the total thing would be 0. Then that would mean that the list was not sorted. Okay. So thus we see that a witness that proves a list is sorted does not have to be the sorted list. It can also be the input to Boolean formula that we created above. Does it make sense? Like I sorted a list and I can give that list to you to verify it, but suppose I do not want to give you the sorted list. I only supply you the values of p1 to p4 and q1 to q4, and if that satisfies this satisfiability problem, then that means I've done my calculation correctly. So congratulations, we just generated a zk proof. Nice. I mean, it was not a zk proof, but like dramatic effects. So the knowledge and zero knowledge proofs refer to the knowledge of the witness. zk proofs are concerned with the verification aspect of computation. We already told you that. We are not concerned about how you calculated it, did you calculate it correctly, we don't care. We just want to verify your solution, that's it. And to verify the solution, we create another model of that problem. If you can give me a solution to that, I'm happy with you, whatever you did. zk proofs seek to demonstrate you know the witness without revealing it. Fine. zkPs work only for pure NP problems, unusable for problems which cannot be verified efficiently. If Boolean satisfiability problem, that the Boolean formula that came up, the solution to that itself was exponential time taking, then it does not make any sense to model that problem into a Boolean satisfiability problem because it's taking exponential time. So the verification has to be done in polynomial time. For both P and NP problem, the verification of the solution can be done efficiently. It's fine. Has anybody studied heuristic algorithms here? A little? Yeah? Like if anyone you have done ML problems, then segue into that. Okay, fine. So this is all zkSync sharing stuff. I think it is fine. I'll just give you a short thing of what's happening. So you now understand how a zk proof works, right? You create a model of a problem to verify it, that's it. Now, when you are running solidity on the EVM, that's broken down into opcodes or the assembly, and you just have to generate the zero knowledge proof for all the things that are generated in the assembly. That's it. That's how you create a zk rollup, and of course post that proof on L1 so that we know that you did not do some bad stuff. If you are interested in learning about zk and want to know the current state, zk is being used for zk proofs are being used for scalability, that is increasing the speed of Ethereum, for privacy, privacy as in I do not want to broadcast to the blockchain that I am sending this amount to that amount, like that person. So that is achieved via something called Zcash and the Monero chain, whatever. And verifiability also, like you can prove something that you have been a member of this organization for that long without actually revealing your identity. So that is the use cases for zk. And if you want to learn more about zk, the first thing is learn a little about abstract algebra, see how things look to you, then learn about Blanc and FRI. I mean, there is also R1CS, that should be the first step, but whatever. Programming comes later, circom, arrow to nowhere, whatever is. Yeah, so if you want to start learning about zk proofs, we have an awesome repository called matterlab/awesome zero knowledge proofs. This repository will help you take you from like absolute zero knowing nothing to being decent at understanding how zkPs work and being able to work with it. Vitalik is the co-founder of Ethereum, and he has written extensively about zk proofs. You can read his articles; they are like really good. Okay, that's nice. Oh, by the way, the last thing, the Tornado Cache paper, that is a walkthrough of one of the most famous zk protocols by my colleague Porter on YouTube. You can also check that out. Questions? I mean, I'm done now, so yeah. If you guys have any questions, then thank you for sitting this long. I seriously did not expect everyone to sit, so yeah, thank you. So if you have any questions, now's the time. If not, then feel free to DM me on Twitter @Saxena. Thank you.